So, using the calculator to get our normal distribution probabilities, um, let's start with a simple thing, something that's easy to work with, -1 to 1. From the empirical rule, we already know that that should give us 68% or 0.68. With as we'll see, there are actually some more decimal places after that, but it does round to 0.68. So the probability that the z-score is between -1 and 1. So we're actually going to go to a familiar place, this distribution command. So you have to hit, see as it's in blue, you have to hit the second button first to get into that menu. And this is the same place that we found the binomial PDF and the binomial CDF commands. But fortunately, we don't have to scroll down. The normal commands are right at the top. You will never use the first one. You will only ever use the second one. The first one, the normal PDF, I don't know why it's there. There really is no point to it. The normal CDF, however, that one, yeah. So that's the command we're going to want to use. Now, like you would have seen with the binomial PDF or binomial CDF command, there's a menu or a list here where you get to type in the different parameters for the command, which is very nice if you have it. For those of you guys that have maybe an older calculator and don't see this, yours takes you right back to the main screen. You're going to have to type them in the right order manually, which is fine. I'll show you that in a moment when we all get there. But in this case, what you probably see starting out there is something like this, -1e99, -1e99. That's scientific notation. That is -1 with 99 zeros behind it. That is an incredibly large negative number. It's the calculator's version of infinity, or negative infinity in this case, because the calculator can't actually do infinity. There's no infinity symbol. It doesn't actually work that way. It needs an actual quantity to work with. So we give it an insanely large negative number to do negative infinity, and it gets the point across. Now, we don't need that for this problem, so we're just going to clear that out. We need to go from -1 for our lower bound to +1 for our upper bound. Now, the mean and standard deviation are by default set to the standard normal distribution parameters, a mean of 0, a standard deviation of 1. So at least for this first lesson, there's nothing we should have to do to change them. We go down to paste and hit enter. Now, for those of you with the older calculators, when you selected the normal CDF command, it would have brought you right back to the main screen. You would just have to type these things in as you see them here. The lower bound first, -1. The upper bound second, the mean, and then the standard deviation. But regardless, once you get to this point, you hit enter, and there it is, 0.6826, etc. 0.68, exactly what the empirical rule said we should get. Now, well, this has more decimal places, but it certainly does round to 0.68, as the empirical rule would suggest it should. The reality is that there is always going to be a lot more decimal places than just 1 or 2. That it's exceedingly rare you'd get something that exact. So you're likely going to see a lot of decimal places. The typical convention is to round to 3 or 4 decimal places, depending on who you ask. But you do whatever the rules are in front of you. If something in the homework says round to 2 decimal places, then that's what you do. If it says round to 6, then that's what you do. But typically 3 or 4 is the standard. Now, this is kind of like a meaningless thing, in the sense that this is just weird computer commands and numbers and things that popped out. It really does help when you're doing the normal distribution questions to draw out or to see a picture of what it is you're looking at, to see the bell curve, and to see the appropriate region shaded. So the way we do that is we're again going to go back into this distribution button. but there's a draw command over here. There's a secondary menu, draw, and there's several options in there. The second, third, and fourth refer to other types of continuous distributions that if you take statistics 2 or beyond, you might see them and deal with them, but in this course we're only going to deal with the normal distribution, so that's the very first one up there. Now, before I get into this, when we do this, it's going to take us directly to the graph. And the normal distribution is actually very, very small in the scheme of things as far as graphing goes. Like, if you were graphing a line in an algebra class, you might set up your axes so that you could go, up about 10 spaces, down about 10 spaces, left and right each about 10 spaces, so that you got plenty of room to draw a graph. That is way, way too big of an area for the normal distribution. So before we start doing this, I'm actually going to go up to the window button up here. We need to set our window dimensions so that we can actually see the normal distribution. Now, think of the normal distribution pictures that I used in the PowerPoint. If you look at the horizontal axis, we have it set up so that the 0 for the mean is in the middle, and then it goes 1, 2, and 3 standard deviations to each side, and it doesn't really show much beyond that. I mean, a little bit, yeah, but really there's not much point to it, because remember, the empirical rule tells us 99.7% of all of the data is going to be within 3 standard deviations of the mean. That means those two tiny little tails out to either side together have 0.003 area. So unbelievably tiny, barely worth talking about. So as far as the graph goes, going out to negative 3.5 on the left and positive 3.5 on the right, or if you don't like the decimals, you could do a whole number and do negative 4 and positive 4. That's plenty for what we need to see. So the X scale, as it says up here, is the distance between the tick marks on the axis. It should count by ones, just like we have on the standard normal distribution. Negative 3, negative 2, negative 1, 0, etc. Now, as for the y-axis, the entire bell curve is above the x-axis, so we don't need to see any negative y values. So 0 is a good bottoming out place. As for how high it goes, believe it or not, the normal distribution, that bell curve, is very, very flat. I mean, I kind of enlarged the graph in the PowerPoint so you can see how it peaks up and makes that bell shape, but in the great scheme of the universe, it's actually very, very tiny. I mean, think about it, the whole area underneath it has to be equal to 1, which means it can't be very tall. So if we have the screen show up to 0.5, that's probably going to be enough. So our X-min and X-max as shown, our Y-min and Y-max as shown. I'm going to quit now back to the main screen, and now we're ready to go and do our drawing. So I'm going to go again into that distribution menu and slide over to the draw menu. I'm going to select shade norm, and we're actually going to have to put in the same parameters that we did with the normal CDF command, because still doing the same thing. We need to know how far to the left are we going to shade it, how far to the right are we going to shade it. And the mean and standard deviation by default. Now, if you have a color calculator, you'll get this option, which is really kind of nice if you have it, but if you don't, no worries. If your calculator is black and white, that's fine. You just won't see that line there. You can scroll through to select some colors if you want, whatever floats your boat. And when you're all set, go down and hit the draw button. And when you do that, it will take you directly into the graph and shade the appropriate region. There you go. There's our normal curve from -1 to +1. And it even tells us our area at the same time. Actually, you might not even use the normal CDF command. You might just use this drawing command if it's available to you. It depends on your calculator. Not all calculators are exactly equal. If you happen to be using an older one, like a TI-82, I don't believe it does this, but the 83 pluses and all the 84s should do this. So pretty straightforward, pretty simple. Everything's in the distribution menu, either the normal CDF or you go in there and then scoot over to the draw menu and do the shade norm. Now here's an important thing. If you are going to use this, the calculator do this, and you do want to have it draw like that, this picture that's drawn here is going to stay there even after you quit back to the main screen. So if you want to do a different problem, you need to clear this off before you do anything else. And the way you do that is, oddly enough, I know it's a separate draw command, but right here next to the distribution command is one that says draw. And the very first command in that menu is clear draw. You're going to need to hit that, and it will clear off the entire thing so that you can do your next problem. Now, as for that 1E99 thing, the calculator tends to use that by default. So let's try a new problem. Let's suppose we want to do the probability that the z-score is less than 0.25. Now, if it's less than 0.25, and see, this is where the calculator gets a little bit, I think, not the most efficient way to do this. I think there is an element where you need to do this by hand, because the calculator can draw the normal distribution for you and shade the right thing, but you got to know the commands to put in first. And the fact of the matter is that it's actually better, I think, to have the drawing before you do this, which is why in another video I show you that idea of drawing out the normal distribution and shading the appropriate sections. So bear with me on this one. If you're doing from 0.25 and everything less than it, that means you want everything to the left of it. And it's going to keep on going to the left forever. So on the left side, you need that to go out to negative infinity. How do we do that? Well, we can use the calculator's version, -1, and then the way we get that capital E is actually this double capital E right here above the comma button. Not this one, not that. The double capital E here. I know, it's weird. It is weird. I wish they did it differently, but that's how they do it. And then 99. As for the upper limit then, that's how far to the right are we going to go, and that's 0.25. Now, admittedly, that -1E99 thing gets rather annoying. So let's think about that for a second. Earlier I said that the tails of the distribution, those tiny little sections way out to the left and right, are so small as to almost be non-existent, as to be so little they make almost no difference whatsoever. So rather than do this confusing -1E99 thing, you could just type in a fairly large value like -1000. It's going to get the same point across. And I'll show you that. Let's do it with the -1000, and then I'll show you with the -1E99. So, -1000 to 0.25, because -1000 is a large negative number. It goes way far out to the left. 0.5987, etc. Now, I'm going to go back in and do the normal CDF again. This time, I'm going to do the same thing, except I'm going to use the calculator's version of negative infinity. So see, everything's the same, except instead of -1000, I'm using the calculator's version of negative infinity. And, fancy that. The answer looks to be the same. Now, they are different if you go way out to the right. there's eventually going to be a difference in the decimal places. But if we're going to be rounding off to 3 or 4 decimal places, as far as we're concerned, these things are the same. And it's a lot easier to work with. So my suggestion is use something like -1,000 for when you're supposed to do something that's unbounded on the left, or something that's unbounded on the right, use +1,000. And it's just easier to type in. It will still give you the right answer, and it's totally fine. So that's how you use your infinities as you need to. Just a very large value that's either positive or negative, depending on which side you need it on. We can have this thing, again, shade it, which is probably not a bad idea to do after the fact here. Now, this, again, by default has that negative infinity in there, so you can leave it, but I'm going to type in -1,000. Going to go up to 0.25 and draw. And there's our picture. It shades 0.25 and everything that's less than it. So you can see how that's just, here's the center. That would be the 0.5 mark. Everything to the left of this is 0.5. So this includes an extra little sliver here, just to the right of it. That makes it go a little bit above 0.5. So the answer seems to make sense when you look at the picture, but perhaps you can see how if you had the picture to begin with, it might be easier to understand why it is you need a negative infinity for the left and the 0.25 for the right. So that's what that other video is about, is to help you see drawing it first really is helpful. So again, there's another video for Excel, which I'll get to in a moment, and you can watch that if you were using Excel or if you're using a calculator, whichever works for you. But I do highly recommend you watch the other video that shows you about drawing it by hand first, because I do get into some other topics in there.